Okay. So good evening, everyone. So in today's lecture, I had promised that I would be discussing base rule. So let's get started with that. Just a minute to set things up.
Do we have any more session before this one?
Uh, Not from us. Maybe the TA might take a session, but not from us. This is the only session before the quiz.
Who can take the session?
Huh?
Who can take the session? Sorry, I didn't get that.
Pardon me?
Who can take the session before quiz?
This is a session before quiz. The another session, if the TA takes it,
Okay,
the
TA.
teaching
Oh,
assistant, if he takes it, it will be there.
okay.
Okay, so I hope my screen is visible. Yeah. All right. So this was the question that we were discussing the other day, and I got a bit confused with some things. So coming back to that question on base rule. So before we start, what is base rule? Base rule is basically a mechanism by which you would be able to convert joint probabilities and marginal probabilities into to get a posterior probability. That is basically the funda. Or in more simpler terms, the probability of an event A happening given that some event B has happened. This is basically the posterior probability. Updating the probability of A given that some event B has happened is nothing but the joint probability of A and B happening divided by the marginal probability of B happening. Okay, so that is base rule in a nutshell. Yeah, that is base rule in a nutshell. Now we are going to use this to this problem that I was showing on screen. Alright, the same problem was discussed last time. I'll just give a minute, just take a screenshot of it so that you can also read it simultaneously. Okay. So now let's see what is given. I am a student and I want to apply for a visa for a country, right? A student visa. And I have two options. I could either choose center. I could either choose center A or center B. Okay. Base rule is same as conditional. Yeah, it is a conditional probability, probability of event A given B is happening. So it is a conditional probability, yes. Okay. So I have two centers, centers A and center B. Now, the information that is given to you is the visa processing center, let's say the embassy, is going to be accepting 65% of visas from A and 35% of visas from B. Okay, so this is the information that is given. So the probability of the visa being got from A at the embassy is 0.65 and the probability of it being got from B is 0.35. Right? So this is the first information that is given to you. So the marginal probability of A and marginal probability of center B. The next thing that they are said is once you apply from a center, what is the probability of it being granted? So historically, what they have told you is historically 70% of applications from center A get granted and for center B it is 80%. So this is the information that is being given to you. So in terms of probability, what does this translate to? Okay, I cannot see all the chat right now. I'll complete my discussion, then I'll get into the chat. So the question to all of you, if this is the statement that was given to you, historically 70% of the applications from Center A have been granted a visa and 80% of applications from Center B have been granted a visa. What does it translate to in terms of probability? What is the probability that you get? This is marginal probability. What does this statement translate to?
Sorry, sir, the question is not very clear.
The question in the sense this is not very clear or what I am asking is not clear.
What you are asking is not clear.
Okay, so my question is historically 70% of applications from Center A have been granted the visa and 80% of applications from Center B have been granted a visa. So this particular statement in the question, in terms of mathematical notations, what probability that is converted to? That is being given to you. What is that
Probability of granted given it is from A? I mean,
Yes.
probability of granted given that it is from a center.
Fantastic. So what is that called?
The conditional probability.
It is?
Prior.
The conditional probability.
It is the conditional probability. So this is the conditional probability that I will get granted a visa if I apply from A, that is going to be 70%. And similarly, the conditional probability that I will be granted a visa if I apply from B is 80%. This is the information that is being given to you. All right? Everyone with me so far? This is a conditional probability. Last time I took it wrong. I took it as the joint probability. That was the error. This is the conditional probability. Everyone clear?
Yeah.
All right. Now, what do I want to find? So all of these informations have been given to you. And with this, you want to take a decision. But all of a sudden, your friend, someone has applied for a visa and he has told you that it was rejected. That is the new information that is coming to you, right? With this information, if you want to choose an application center, what should you find out? What is to be found out if you are given this new information that the application was rejected but the center was not told? What do you have to now find out?
Probability of it being a certain application center given that the application was rejected.
Exactly. So what is that basically? What kind of a
Center
conditional
given J
probability is
complement.
that?
We'll have to calculate A given J complement and B given J complement.
You want to G complement, fine, fantastic. So I just want to find out what is the probability of A given that instead of G complement, I'll just say rejected because opposite of granted is going to be rejected. And what is the probability that the visa was applied from B if it was rejected? These are the two probabilities that I have to find. And I want to make a choice such that since I'm going to apply for a visa and my goal is to get granted, whichever is lower, that center I will choose. Okay? And so I want to find this conditional probability. One second, let me just finish. This conditional probability given that a visa was rejected. Yeah.
So instead of rejection, can we look for the acceptance?
Why do you want? How can you look? I've not told you whether it was accepted. No, the new information that is given is for rejected.
Okay, reject.
So
So we
you
record.
must compute only for rejected.
Okay, good.
All right. Everyone with me till this point? Yes. No. Can I get some thumbs ups?
Yes, sir.
Can you repeat it once more if it is?
Sure. So a new information has come in that someone's visa was rejected.
Right. Right.
REJCTED, rejected. So with this information, I want to now update and get a new information that is going to tell me what is the probability of that reject coming from A, what is the probability of that reject coming from B.
Okay.
Okay. So that is the new, this is the new information. And with this new information, we want to update this.
Okay. So
Okay.
probability of rejection coming from A and probability of rejection coming from B is the computation that you're doing there.
Probability
Oh, the
of,
other way around.
no, it's
We
the other
already
way
know
around.
the rejection given that A. See, if it is granted in A is 70%, then rejection in A is obviously going to be 30%.
Correct.
That is already known to you. You have to find the other way around. A, given that it is rejected, that is what we have to find.
Probability that the visa application went to A given it is rejected.
Exactly.
Okay.
So
Okay.
what are you updating? So now the question comes is, among all the given information, which probability are you updating? Bhavya, don't say, but someone else. I believe Bhavya would have understood, but someone else, which is the because in this is now the posterior probability. Whatever I've written in red is the posterior probability. All right, this is the posterior probability. So if it's a posterior probability, it must update something. So which of these numbers is it updating?
It's going to update 0.7, that is.
It is going to update 0.7.
We are actually getting some information about what is the chance that this particular application has gotten rejected at center A, correct?
So you're getting what the information that you're getting is it was rejected. Based on that,
Yeah.
you're updating what probability? The information, once the information is got, the probability becomes this thing 100% because it's an event that has happened. There's no probability of that. It's happened. It's past.
Right.
What are you updating based on that?
I'm updating the chance of rejection.
You're not updating the chance of rejected. No, you're updating the probability that it came from an event. If this event has happened,
Yeah,
if
what
the
are the chance?
rejection has happened, what is the chance that it has come from A?
Correct.
What is the chances that come from B?
B, correct.
So the event has already happened.
Okay, then I'm updating whether which center has, the 65 and the 35 is what I'm actually,
Exactly.
probability it has gone to, okay.
Yes. So if you look at this particular updation, this is basically updating probability of A and probability of B.
Okay.
Historically, this was the fact. Now, given that it was rejected, what is the probability that event came from this thing? So, without this information, if someone tells you that they have just applied for a visa, you would have checked the probability that it is going from either the visa is going from A is 65%, and the probability that visa is going from B is 35%. Now, with the new information that it was rejected, you are going to tell that the probability that it went from A is this number, and the probability that it went from B is this number. Got it? Everyone clear? Can I get a thumbs up if everything is clear?
Yeah.
So this is the problem. Now tell me, how will you find out probability of A given R? What is the base rule for this? Because now it's now a posterior probability. And if you want to find a posterior probability given past information or prior probabilities, how will you write this?
So P of A given R is equal to P of R given A.
R given A.
We can just use the standard base theorem, right?
R given A.
Yeah, R given A multiplied by P of A.
P of A, no. Okay, fine. P of P of R given A into P of A.
Divided by,
No.
you have to
No, I
still
think
divide
I divided by P
What are you
of R.
telling? No.
P of R.
Yeah.
Divided by the P of R.
Okay, let's not get into this. Wait, let's use the standard formula because people will get confused. What is this? This is the event that you want. Then what is it?
P of R intersection A divided by P of A.
P of R intersection A
Divided
divided
by
by P of A.
A.
So the joint probability divided by, hey, one second, P of A, wrong.
P of R.
It's always the denominator. Whatever is here, it comes here. Just remember base rule as that. Whatever you put the bar sign by, that comes as a denominator division. Just remember this as P of A given R is basically read as, for mathematics purpose, for cheat code, P of A divided by B, A by R. So the numerator is always A intersection R, denominator is always by R, right? So P of R. That is how you usually remember it. Let's just use that directly. You can always substitute this with something else and get it. You can always write this as P of R given A into P of A by P of R. All right, all of that is possible, but not for us. Okay, because I'm going to do it as computations later on. All right, so this is what you have. So you have the joint probability divided by, this is basically nothing but a joint probability divided by the marginal probability. Correct?
So the upper part, can we say P of A given intersection R instead of R intersection A? Both are the same, right?
That
P
shouldn't
of
make a
A
difference.
intersection R is equal to P of R intersection A. In Venn diagram, this is set A, this is set R, this is the intersection. Whether it is A intersection R or R intersection A are both the same, right?
Right. Oh, okay.
So R intersection A or A intersection R is the same thing. Okay. Now this is what we want. P of A given R is nothing but P of R intersection A by P of R. Now tell me, what is P of R intersection A?
0.3.
How? I want the formula. Now tell me what you told. That is why I said I'll go step by step.
No, we already know that probability of probability of G given
What is
A,
given A?
A is 0.7.
Okay.
So from this we can extrapolate that if it is from center A and 70% applications got accepted, then the remaining 30% obviously got rejected.
Okay. So P of G given A is 0.7. And you are telling P of what is this?
D complement or R.
Okay. R, that is all.
R
P of
given
R is
P of R given A.
given A is 0.3. That is fine. But how is that P of R intersection A? This is conditional probability.
Multiplied with P of A, right? P of R intersection A.
Exactly. So I want you to tell me the formula.
P of R intersection A is equal to P of R given A into P of A.
How did you get this?
Again, joint by marginal is equal to conditional. So joint is equal to conditional into marginal.
So exactly. So according to base rule, P of A intersection R is equal to P of R given A into P of A, which is equal to P of A given R into P of R. Right? Yeah. So that is basically base rule. This is the beauty of base rule. So it basically is able to compute the joint probability in terms of marginal probabilities and conditional probabilities. So P of R given A into P of A divided by, now tell me what is the marginal probability of P of R? We want P of R, right? So what is P of R? Probability of event R happening.
We'll have to add together the conditional probabilities, I guess.
For what?
So 0.7 into 0.65.
No,
That
tell me
is
the formula. Don't tell me the numbers. Tell me the formula so that everyone can follow. What is the
P
probability
of
of rejection?
1 minus
1 minus.
the probability of the visa being granted. And now we can calculate the probability of the visa being granted because that information is already given to us.
Okay. Fine.
This might be a very convoluted method, but
Okay, but I can directly find out P of R given this thing. No, P of R, right? What is P of R?
PFR is A intersection R divided by
What is P of R?
R given A
the
into P of A.
Okay.
P of
How?
A intersection R divided by P of A
given
Okay, wait 1 second. P of
conditional R.
A intersection R divided by
P of A condition
Yeah.
R.
P of A what? P of A given R, right? Okay.
Given R.
Okay. That is all. I'm asking
you still need
probability
the
of
plus, right?
rejection.
You
Plus
need
what?
about the B also, right?
So this is the marginal probability for rejection across both centers. So this is for center A, this is for center B. Sorry. Writing it cross. 1 second, let me just not rotate it now. Okay, from now I'll rotate and write. P of B intersection R divided by P of B given R. Okay? Okay, but there is an even better way to write this. What is the probability of rejection?
P of R given A into probability of A plus P of R given B into probability of B.
Okay, how are you writing that? In this, you are basically substituting P of A intersection R. You are just substituting, but even more intuitively. Okay, let's do it like that only. It's more simpler to understand. What does this basically translate to? P of A intersection R is what? P of A given R into P of R. Sorry. What is P of A intersection R? It is P of R given A into P of A. Correct?
Correct.
1 second. What are you guys
so we'll
done?
have to first calculate it from that above formula R given A into P of A.
1 second.
Sir, I have
No,
a small doubt.
Well, yeah, this is wrong.
Yes, so
Plus
that's why
will
I
not
was
come.
that's why I was
Yeah, the
saying
plus
it
will
would
not
be
come.
long method.
Sorry. Yeah, the plus will not come.
Is it a multiplication?
We are stuck in the same three variables.
No need.
We have to incorporate the probability of being granted because that is what we are given.
This is itself a marginal probability. So if you are telling P of R, then you are basically telling P of A intersection R by P of A given R. This itself directly gives you everything. Because, right? The problem comes.
So we still have to find A intersection R.
So you have to still find A intersection R. So that is why this will not work.
So, sir, can we not say, because we are trying to find probability R, so either it should be rejected from A or it should be rejected from B. So can we not say it's equal to probability of rejected from A and plus probability of rejected from B. So it's equal to probability R.
Correct. That is what I'm trying to drive at. That is what I'm going to now tell you. So instead of doing all that, it's going to be rejected from A. Reject from A plus probability
Plus rejected
of
from B.
reject from B. So what is the probability of rejecting from A? Yeah, you're right. Whatever you have written on the screen is right. So probability of A into probability of rejection given A plus probability of B into probability of rejection given B. This is your marginal probability of rejection. That is the probability that it will be rejected from A, and this is the probability that it will be rejected from B. So this is nothing but probability of A intersection R plus probability of B intersection R. That is your probability of R. What is A intersection R? It is probability of A into marginal probability of A into probability of rejection given it is coming from A. Similarly, what is the probability of B intersection R? It is the marginal probability of B into probability of rejection from B. Okay?
Sir, can we represent conditional probability in a Venn diagram?
You want to represent
Conditional probability in a Venn
which
diagram, just like
this
yeah.
one.
Yeah, just like a intersection R represented the intersection of both circles. And then what R intersection R given A represent?
If I do this, all right, I have A or B, correct? So you want me to draw what?
R given A.
Probability of rejection given it is coming from A, correct?
Yeah.
That you cannot represent in this thing, no? You cannot represent it in a Venn diagram. Given an event, you cannot represent it. Basically, this will be a subset of this. So you cannot represent it in a Venn diagram.
Okay.
So that will not work.
So you can shade the area of A, and the intersection part is that R given A.
That will not come now. If I shade the area of A, it's only probability of A.
Yes, and the intersection part is R given A.
The intersection part is basically A and R, no? That is both A and R. If you ask me to shade this region, it is both A and R.
But
Probability of
given-
A and the probability of R. That is
This
intersection.
would be A intersection B, not A condition B.
It will not be A condition B. So you cannot represent condition in Venn diagram.
Yeah, it's because it's a little bit confusing because whenever we
This is intersection. You cannot do condition in Venn diagram. Or at least
for
I'm not able to immediately
for the area, given the area of A, it is it acts like a conditional probability. I've read it and I'll put it on discourse.
No, that is okay. You can put it on discourse. But what I'm trying to say is, here, if I shade this region as this thing A R given A or A given R, this is basically intersection. This is more clear for intersection than given.
Okay,
Unless I
okay, then go ahead.
explicitly specify that it is a given, it does not make sense. And since I've already used intersection diagram over here, I don't want to confuse it again with given. So let's just say that this region is intersection and not go into Venn diagrams for conditional probabilities. Okay? It is not that it cannot be given, but it may just be more confusing.
Excuse me.
Yeah.
So this Venn diagram I did not understand basically. One is like
Don't get into this Venn diagram.
We have two centers, right? So two centers and rejection completely it has to come either from one of these two, no? So there won't be any component.
What if you go and give the application directly to the embassy, post it without going through any of these two centers?
Okay, that possibility is
that is also there. Those are imaginary cases.
Okay.
Right? Okay. So this is your probability of R. So now, if I go back to the question, we were looking at finding probability of the application coming from A, given that it was rejected, we had written this as probability of A intersection R divided by the marginal probability of R. We can now write this again as a combination of joint and marginal probabilities. So, or conditional and marginal probabilities. So that will become probability of
Probability of A, probability of R.
rejection given A
Given
into
A.
probability of A divided by
Probability of A multiply probability of rejection condition A.
Yeah,
Plus
yeah.
probability
So probability of rejection given A into probability of A plus probability of rejection given B
given B
into
multiply
probability of
probability
B.
of B.
Right? So that is how you write. Now you can directly substitute these values. These are given. So your problem basically gives you probability of granting given A. And inside event A, there are only two options. I will either get granted or I will get rejected. Right? So once I give my application in center A, I can either get the event as granted or it can be rejected. So when I have probability of grant given A as 70%, the probability of reject given A is going to be 30%. So that will be 0.3. What is the marginal probability of A? That is going to be 65%. That is going to be 65%. So 0.65 divided by 0.3 into 0.65 plus similarly for B. Again, I have two options for B, grant or reject, right? So if it's granted 80% of the time, then it's rejected 1 minus 80% of the time. So that would be 0.2 into 0.35. So do the computations and you should get.
So P of A given R is 0.73.
Yeah, so P of A given R is 0.73. So what is P of B given R?
1 minus 0.73.
How can that be?
Yeah, 0.27. Because if it has to be rejected, then there are only two avenues, right? It can either be rejected from A or it can be rejected from B, correct?
Okay, let's take it that. Fine. All right, let's take it as that. Okay, let's not complicate it. You can do that. You can always do 1 minus probability of A given R. If the rejection can happen only from the two things, so that will be 0.27. Okay, so that is 0.27. So 0.73, 0.27. Now, what is the decision that you will take? Given all of these computation, then which application center will you choose to submit your application, given this additional information? So what is your final conclusion?
B.
Why B?
Because the chance of being rejected from B is much less.
So I will choose B. Okay.
Sir, I had a question.
Hmm.
So what I did was I tried to use another approach as well, and I got the answer as B. But I'm not sure if that approach is right or not. I would just like you to tell me.
Let's do that in the discourse. Just put
All
your
right,
answer that and I'll
all right,
answer.
sir. All right.
Because if you tell me something and I start answering, someone else
Yeah, yeah.
might
Sure,
confused.
sir. No worries.
That's the reason. Okay. Yeah. All right. Anyone else? Okay. In last class, someone had a doubt how this is a posterior probability. This is now a posterior probability because you are updating the probability of an application coming from A. So it's a posterior probability. Originally it was 0.65, now it is 0.73 and 0.27. If the TA does it, you will have a revision class. Okay, so let me go into the chat and see what all do I have. Base rule, set of conditional.
So do we
They-
have any other question today?
No, only this one. So, Kirti, base rule is the same as conditional probability. No, no, no. Conditional probability base rule is a form is a concept that uses conditional probability. Conditional probability is a separate topic on its own. Okay. It gives relation between conditional probability, joint probability, and marginal probability. Yeah, someone has answered. Probability of granted visa given application central from A. Okay. Is that going to be an evaluation session? So I believe I have answered all the same chat messages. So yeah, so this was the only question for today. We'll be taking up regression maybe next week. All right.
So what type of questions will be there in quiz one?
Similar to your mock, you can just check your mock paper. So the questions that are there would be similar to whatever is there in the mock. Mock paper is basically questions from your previous QPs. Whatever questions were interesting, a bit difficult, whatever was discussed, that is only put as mock questions for you this time. There were certain errors in the previous QPs; those are now corrected in your mock. So use the mock paper for all of your this thing, computational correctness.
Okay, sir.
Sir, can you see question number 11 in mock?
Question number 11.
And it will be till week 4, correct?
Yeah, syllabus is 1 to 4.
1 to 4, okay.
8, 9, 10, 11. Yeah. Suppose a manufacturer. This is base rule, ma. 0.65, 0.3. Total output comes from, and 5% comes from. So here instead of 2, you have 3 places. Instead of 2 machines, it's 3 machines. Just make this correction. Suppose a factory manufactures product on 3 machines, A, B, and C. 65, 95, 100. Okay. Found the vast data is not 1% of A defective, 2 is B, and 10% of C. What is the probability that the product has come from machine B given that it is defective? Yeah. Yeah, just make it as 3 machines and the question is correct.
Okay, so for that we have to calculate a probability of R given B.
What is the probability that the product has come from machine B given that it is defective? No, probability of B given D. What is the probability of it coming from B given that it is a defective? You have now given the fact that it is a defective. Go update your probability that which machine it came from, A, B, or C.
Okay, sir. Yeah.
Right? Whenever you are told something is given, the event has happened. There's no point computing the probability that it has come from some machine. The defect has happened from some machine. You now have to go and check from which machine the defect has come.
So we need to calculate productive is defective given it has come from B.
No, product probability that you will have to compute probability that it has come from B given it is defective. So you have to compute this conditional probability of B given defect. This is what you should compute.
Okay.
So what would this formula be? Let's call this D. So you basically have to compute probability of B given that it is defective. So what would it be? Just tell me the formula. No need the numbers.
We be like probability of defective
D given
conditional
B.
conditional
1%.
Probability
Okay,
of
yeah.
D given B
Probability of Delhi given Bombay.
into probability of B
Okay.
by total probability. P of A
A.
into P of D given A
Okay. Then it's got
plus P of B into
into
P of D given B plus P of C into D given C.
That's all. So this is basically nothing but probability of this is nothing but probability of B intersection D by probability of D. Okay, this is what you should compute. Given event, once an event has happened, you are updating the probability that it has happened from that source. It has happened. What is the probability of it has happened from that source? You have okay. You have passed this thing BDM. You have passed because Dr. Milo taught you well. What is the probability of that event happening? So that is basically how it works, right? So this is what this question is all about. Yes, I have a raised hand. Yes, Nikhil.
Sir, can I ask a question about previous question, query about previous question?
Which one?
The previous one that we were solving.
Yeah, centers A and B.
No, the first one. Yeah, the center A and B.
Ah.
Can you go to the problem statement, sir?
Okay.
Sir, here we have prior information that someone had applied a student visa in the past and the application was rejected. If that prior was that the application was selected, would the answer be different?
If the thing was, yeah, your computation should change, no?
But the answer would be same, no?
That
Is
you have
the
to
choice
compute
of
and only
center.
see. That you have to
Choice of
compute and
center.
only see. That number games, like, I'm not that good at math, so you'll have to compute and only see. G given
the
A,
choice.
G given B. For some reason, if the scale tips in one direction, it can happen.
No, the final answer, choice of center.
That is
Would
what I'm
that
trying
be
to say.
same?
No? You have to compute and say. I have to do the computations, the numbers, and then only I can compute.
Okay. So I tried doing that, and yes, the answers are different in that case.
So answers are different, yeah.
Yes.
So it's basically a number game. How much weightage the numerator takes for a particular thing. So, yeah, you have to compute and see.
Okay.
Sir, can you take one example for null hypothesis problem, sir?
Which null hypothesis? There are two things
chi-square test.
Chi-square, which test?
Tabulated value with the chi-square.
Everything has tabulated value. This thing. Which test? Give me a name of the test. No, I'll answer both.
Degree of freedom, sir.
Degrees of freedom is also there for everything. Any chi-square that you do, you need the parameters of alpha and degrees of freedom. So my question is, which test? I'm asking you specifically this. No. Let her answer. Wait. Why do you guys jump to the gun? Let me ask the student now. So which test?
Goodness of fit, sir.
Okay, then what is the other test called?
Independence.
So there is one thing called goodness of fit. The other is independence. So you must tell me which test. So in this is true for any hypothesis testing. You should always say what is the null hypothesis for a goodness of fit test. What is the null hypothesis for a test of independence? What is the null hypothesis for a Z test for memes? Right. So you should always tell the test name like this. All right. Fantastic. So you want me to tell you the null hypothesis for the goodness of fit test. Correct?
Yes, sir.
Okay. The H naught here is the population follows the proposed distribution, and the alternative is that it does not follow the proposed distribution. Okay, so this is the null hypothesis for a goodness of fit test. I'll also write it because both thing is the same. for the good chi-squared goodness of fit test, the chi-squared test of independence, the null hypothesis is that the
Variables are independent.
Categorical variables are independent. The categorical variables are not independent. Okay. So this is the null hypothesis for the goodness of fit test and test of independence. Okay. Now what you want to know?
Comparing between the tabulated value and the
Wonderful. So in this test, what in any chi-square test, what you basically do is, this is basically a chi-square distribution. All right. Let's not get into what is the x-axis, y-axis, and all, but this is how the distribution basically looks like. Okay. I might not be drawing it exactly right, but yeah, somewhat like this. And this is what your tabulated chi-square value will give you. It will give you this cutoff point. This is 0, and then you will have values here. These are basically chi-square values for a particular degree of freedom at a particular alpha. So you are going to tell this is the chi-squared alpha at a degrees of freedom. Okay, that is the tabulated value.
May I interject and ask a question here about the alpha?
Yeah, go ahead.
We normally go for 0.05, or is it something which is constant, or it's specified always, or how does this actually work?
Usually you specify. That works based on your type 1 and type 2 errors, right? You might want to visit your statistics course again, where they talk about type 1 and type 2 errors. Basically, alpha will help you reduce type 1 errors. It's basically a trade-off. Type 1, type 2 errors, it's a trade-off. And alpha helps you to reduce type 1 errors. Beta helps you to reduce type 2 errors. If you reduce type 1 error, type 2 error might go up. If you reduce type 2 error, type 1 error will go up. So that is basically how it works. And universally, it is alpha 5%, 0.05.
Okay.
Universally, that is the number that we use for all of our theory-based things, but it can change. For medical purposes, you might need something else. For manufacturing purposes, you might need something else. That is totally up to a scenario to scenario.
Okay. For this course, we can take it as 5%.
Take it as 5%.
Okay. Thank you.
If you specify something else, you should take that.
Of course.
If I specify 25%, 35%, we will tell you what alpha to look at.
Okay.
Okay. Right. So the chi-squared alpha DOF is the tabulated value. Why? Because it does not change with the computations that you do. It is always fixed for a particular alpha, particular DOF. Okay. It does change in sense how many buckets you use. Based on that, the DOF will change and hence the value will change. But for that particular thing, it does not vary. What you actually do is, then you do some computed value. Let's say there is a chi-squared A that you compute, and there is a second chi-squared. Let's call that chi-squared B that you compute. Okay, A, B just for the sake of names. So you have a chi-squared A, you have a chi-squared B. Now the question that you are basically looking at is, no sample will give you a 0 value. 0 is the ideal. We basically want the ideal value of 0, which means whatever you are doing has no difference with respect to the population. That can never be achieved. So how far away from the population I say is okay for me to accept. Okay for me to to say that I do not reject my null hypothesis. That is the question. So if I get a computed value of chi-squared A, what will I conclude?
Reject hypothesis.
How will you reject? It is before my limit. Now, up to chi-squared is okay. So if I have a value lower than that, if chi-squared A, or let me put it this way.
So chi-square A is calculated, right?
Yes, chi-squared A is calculated. Since chi-squared A is less than chi-squared alpha DOF, I do not reject the H0. Why? Because I am telling from 0 up to chi-squared this thing. Let's call this number also. Let's put a number here so that it becomes more clear. This is 10, this is 9, this is 11, for example. Between 0 and 10, if I get any value, that is not significantly large for me. All right. So for this sample, I have got a value of 9, which is not up to the mark of 10. So I will say do not reject my H0. Whereas for a different sample, since chi-squared D is greater than chi-squared alpha DOF, I will reject H0. Why? Because up to 10 is okay. Beyond 10, I will not be able to say that there is no significant evidence. So I will reject H0. Right? Just this chi-squared alpha is basically like the eligibility criteria. You need at least 65% marks to join some degree in your to join your master's program somewhere. If you get a value that is okay, that would have been this thing. You need at least to be in the top 10 ranks to be eligible for an admission in IIT Madras. You have got a rank number 9. So I will admit you. You have got rank number 11. I will not admit you. That is all. So that cutoff value is given by this chi-squared alpha DOF.
Can I ask a question here related to that?
Yeah, go ahead.
The H0 is saying it belongs to this particular proposed distribution.
Yes.
Yeah. And when I'm actually calculating, I'm getting it as 9. Cutoff is 10. How does it actually help me decide whether it belongs to the distribution on that basis of a number? Because distribution is more of, I'm just trying to understand here. Distribution is more of how the curve is, isn't it?
Yeah. How do you compare that? What is you have bins. You are cutting that entire distribution into bins, right? You have bin 1, bin 2, so on and so forth up to bin n.
Yes.
And then you have your observed value, you have your expected value. What is the chi-squared statistic? What is the chi-squared statistic?
Observed minus expected square.
Observed minus expected, the whole squared,
divided by
expected. Summation of this, right?
Yeah.
So in each bin, you are getting some deviation. O1
Yes.
minus E1 the whole squared, E1 up to ON minus EN the whole squared by EM. Correct?
Yes.
Compared to the expected, how big is the deviation? Basically, that is what you are trying to check now. What is OI minus EI? It is deviation from the expected. How big is that deviation? If all of these are significantly big, my chi-squared will be very big, which means it will go beyond my point. Correct? So when I'm cutting a shape into different pieces, so let's take a simple normal distribution. A simple normal distribution, I'm cutting it into different pieces. In each piece, I have certain frequency that I expect. How big a difference am I getting? Whether all of these differences are significantly large for me to say, no, whatever I assume is wrong. That is the chi-square test, no? Chi-square GOF.
Okay. Okay.
Correct? So if this is a very big value, then it means that in every bin, I am significantly very large. So I keep the 10, and if I get a number greater than 10, then my bins are telling that, then my data is telling that I am not following the original distribution. So I will reject the H0. Why? Because I am doing all of these computation assuming that the population is coming from a particular distribution. What is the expected value? The expected value is TMF into N, right? The probability mass function into sample size. This is your expected, right? And the PMF is assuming that you are originally following a normal distribution, the probability of assuming so many samples under the normal. And if that deviation becomes very large, then obviously the only thing that the observed cannot change because it is given. The only thing that can change is the expected. So whatever you have assumed is wrong. And what is the assumption? The PMF is the assumption, which means the parent population is not following what you assumed. Making sense?
Yeah.
So
Yeah.
that is what this is.
So one question: if the calculated and tabulated chi-square value are the same, so what we are going to do?
10-10, you do not reject the null. Benefit always goes to the null. Benefit of doubt goes to the batsman.
Okay, first one. Don't reject the null hypothesis.
Do not reject. Do not reject the null hypothesis.
Okay.
It is up to chi-squared alpha.
So that means that value is included.
You will not reject H0 up to chi-squared alpha DOF. So less than or equal to. Okay?
Okay, sir.
Let's say we compute. We compute the chi-square.
Okay.
Okay. From there, using the curve for degrees of freedom of the given problem, we can go to the table and then work backwards and see what the P is. Is that also something which
Correct. Yes. That is the p-value method. One second, let me just pull up a table, then it will become clear. Now we will know how good I am in drawing. This is the chi-square, not bad, I was correct. So this is the chi-square, okay? So let's say you have 10 degrees of freedom, right? So at 10 degrees of freedom, I have got a value of, let's say, at 10 degrees of freedom, I've got a value of, let's say, 5. My computed chi-squared. Chi-squared computed is, let's say, 5. Okay? And now what is the p-value is basically, the p-value is, I will go to 10 degrees of freedom. Of course, when you do a computation, that is also for a DOF, because this is nothing but number of bins minus number of parameters minus 1. So that is also having a degrees of freedom, right? So the p-value is going to be this DOF. Go to the table, this DOF 10, and then see at what value you will get 5. 4.87 to 9.34. So your p-value is somewhere between 0.9 to 0.5. Right? More close to 0.9. More close to 0.9. So now what is your alpha? Your alpha is 0.05. I am giving a 5% chance for you to reject H0. What is the probability that you are telling? You are telling me it is close to 0.9. Since my probability of observing the sample, always remember, p-value is the probability of observing the sample given H0 is true. This is always the case for p-value, no matter what test you do, right? The probability of observing the sample given that the null hypothesis is true. What is my probability? 0.9. What am I telling you? If it is greater than or equal to 0.5, then I cannot reject. Up to, even if I get a probability of 0.05, I am telling you not to reject the null hypothesis. That is alpha, significance level. So at 0.9, will I reject or not reject the null hypothesis?
So it is observing the sample.
Observing the sample, given the hypothesis is true.
Okay.
And if that is 0.9, what will you say as compared to 0.05? What is the conclusion?
Accept the null hypothesis.
You never accept. You only say do not reject.
Fail to reject the null hypothesis.
Yeah, fail to reject. Fail to reject H0 or do not reject H0. So that is the conclusion. So as long as your p-value is greater than or equal to alpha, you do not reject the null hypothesis. This is the conclusion. This is the difference between the two techniques. One is the p-value technique, the other is the confidence interval technique. Okay?
Okay.
All of you good? Okay.
One more request. You had taken a session on chi-square tests itself, isn't it? Earlier.
Yes. That was our first live session, I believe. Yeah.
Yeah. Would you be able to share the link? I mean, one of the students actually said they're available in Discourse, but is it okay if I request for all these links to be consolidated for all the classes that you have taken? Because I don't know what I have missed.
I think it should be in the YouTube channel, no?
Problem is they do not come in a sequence.
No, it does. It does. It does
They
come
do?
in sequence. Yeah.
Just give me that link, please, because I'm having
I
terrible
also have
time
to check
checking.
the YouTube channel because I don't go to the YouTube channel very often. No channels. This is the diploma level course. This is the yeah, it is there. Look, if you go there, it is an order. So you had 4 months ago. These are all old videos. I do not know whether this is there, no? 3 weeks ago, 2 weeks ago, 10 days ago, 6 days ago. So they are in sequence. Session 1.
Okay. Could you kindly place this link in the chat window? I'll go with this.
How do I share?
I mean, say just the YouTube link, whatever you have on the
This
top.
one. Okay.
Yeah.
Yeah, this is the YouTube channel, by the way.
Okay.
This is the YouTube channel for BA. I don't know whether you have access to all of these old links. These are all my previous sessions only. So just check them out. But my suggestion, we have changed the way that we are teaching. So if you look at these videos, you might get confused. So don't look at those old videos of 3 months ago. Start with only this term, okay? Because we have revamped a few topics. If you go look at it there, you will get confused for the techniques. So don't look at that. Start from 3 weeks ago.
Okay.
All right.
Will it contain the video of Meta? The link or channel?
No, we are in Meta only, no?
Okay.
This is Meta.
Then we should go through them.
Yeah, this is Meta. These are all Metas.
Before 3.
In fact, the DA has also given you his session. So just look at that.
Planning to discuss the the mock questions some point of time before the exam?
No, ma'am. I don't think so. I will not be discussing. If the TA does, then okay. But I'm not going to be discussing. the mock questions. Most of the mock questions I've solved during your live session, so you should be able to match. Most of them have been solved because they are also previous year questions, and during my live sessions I am taking previous year questions to solve. So you'll find a parallel. Most of them I've already solved during the live sessions.
Okay.
Yeah. Okay, anything else from anyone else?
Do we have a session between now and the exam?
No, not from me.
Okay.
All right. Any other questions?
Yeah, so question number 17 in mock. Is it talking about the degree of freedom?
Question number
17.
Yeah. In goodness of the test, if the days are taken as buckets, what is the number of degrees of freedom? Yeah, you have to find the degrees of freedom. What is the number of degrees of freedom?
Answer is given 7.
Okay.
I don't know how to get 7.
What is the formula for number of degrees of freedom?
Number of rows minus 1 into number of column minus 1.
Wrong. Go see my video lecture of week 3, I believe. Week 3 and week 2. There are two chi-square tests. Yeah, someone has put it. There are two chi-square tests. What is the test here? That is why I asked you the name of the test.
Okay. Oh, sorry, sir. Goodness of it.
It is goodness of it. So there are always remember chi-square. There are two tests. One is GOF. The other is test of independence (TOI). Goodness of fit. It is K minus P minus 1. Number of bins minus number of buckets minus number of bins minus number of parameters that you compute minus 1. In test of independence, it is it's going to be a this thing table basically again. There it is number of rows minus 1 into number of columns minus 1. Number of row categorical variables, number of column categorical variables. Yeah.
Yeah, okay, sir.
So there are two different tests.
Sir,
Yeah.
for any distribution to be symmetric, it is necessary to have skew equal to 0 exactly, or is there any tolerance?
No, there is some tolerance. You will never get skew equal to 0. There is some tolerance. It varies. If you look at just Google and find out now.
Okay.
I don't exactly remember. I think it is 3. Yeah. I think it is 3 up to 3, or is it for kurtosis? I don't remember exactly.
No, sir. I will search.
Zero is the ideal. Zero is the ideal, but you'll never get 0. You'll always have a small value.
Okay.
Riju, I'm not able to hear you. If you turn on your mic, it's just giving me static. Okay, any other questions? Okay. Right, if you don't have any questions, you can log off. We have 20 people on the call. If more than 10 of you log off, then I'll also end the session.
All right. Thank you very much.
Thank you.
Have a good night. Bye.
Bye-bye.
Thank you, sir. Thank you, everyone.
Thank you. Good night.
Thank you very much.